Okay, so today we're looking at set notation. Okay, now set notation is a way of thinking about Venn diagrams and the way that they are set out. Okay, now there's a lot of different things that we need to know with set notation. There's a few different symbols, so I'm going to draw some of them, and then we'll talk about it. Okay, so let's have a go at some of these now. The first one I'm going to draw, now we've already had a little look at this, is this one here. So it's the way I'll just show you how I draw that, okay? I draw like a backwards 3. If you want to just draw a backwards 3 like that, and then you can put a flick on the bottom and a flick on the top like that. So backwards 3 with a flick on the top and a flick on the bottom. Now this means everything. Okay? This means everything. So this little symbol here means everything. So usually it's everything which is inside my rectangle, okay? So if I draw a rectangle, it's everything which is inside there, like so. So let's have a look at some others now. So let's have a look at, let's say, just A. So if I'm looking at just A, let's just draw another rectangle here. Now, if I've got two circles which overlap, like so, there we go. And I'm going to call this one here A and this one here B. Everything which is just in A is everything which is in A circle. So this part here, like so. So that middle bit and that bit on the left. So this circle here represents what A is, okay? I shouldn't say just A, should I? So I should say in A. Sorry, my fault. I wrote that wrong. This here isn't just A. This is everything which is in A. Everything in A, okay? And in a very similar way, if I wanted to do this for B, I'm going to copy that. Okay, if I wanted everything in B, well, that's going to be everything which is on the left-hand side of the circle. So this part here is in B, and this part here is in B as well. So it's the whole of that circle. That everything there is everything which is in B. Everything in B. Okay. So that's kind of the starting point of this. Now you could, if you want to, you can put like the little backwards 3 outside of these, because that shows that it's everything. Now what we're going to look at next is we're going to look at everything which is in A and B. So let's write down here, in A and B. Now there's a special symbol for this. A and B looks like this. It's like a N shape, okay? And that means and. A and B. So if I'm going to draw this, then it needs to be everything which is in A and B, which is just this middle bit here. Okay? So this is in A and B. And this symbol here means and. So get that down. So the next one, we've done A and B. The next thing we need to think about is A or B. Now this has got a new symbol. This is an upside down, it's like a U shape. So A or B. Now this one here means or. Okay, so in A or B, it means it needs to be everything which is in A or in B. So that part there where it says or, it needs to be, so everything in A, which is going to be this part here, and this part here, this part's in A as well. So I highlight everything which is in A, or everything which is in B, which means it needs to be this part here. You've got to really understand what these mean. So, and means it must be in A and B. Or means it can be in A or B. And the symbols which are really important are this symbol here, which means and this symbol here, which means or. So get all those down. There's one more thing we need to think about. There's one more thing we need to think about. And that's the not symbol. Now the not, in fact, let's write this down actually. Let's write this down over here. The not symbol is a dash. So this here means, that little dash means it's not in A. Okay, or if I had this one here, this B dash means it's not in B. So if I then draw my Venn diagram here, so if I wanted everything which is not in A, well, I know that everything which is in A is this part here. So this is everything which is in A. So how would I draw everything that's not in A? Well, to draw everything which is not in A, it's going to be everything which is not in A. So it's going to be the outside part here and in this B part here. So everything which is outside of this circle here. So this is everything, and this is what you need to highlight or talk about. Everything which is not in A. So everything which is not in A is going to be all of this. Like so. So that's everything that's not in A. I could do everything that is not in B, which would be everything which is not in that B circle. So let's just have a look now at what all of these are. So we've got our everything, which is that E, we've got everything which is in A. There's two little dashes there. I don't know what they are. Let's get rid of those. Looks like you've got dashes. So everything in A, like so, which is just everything which is circled. Now I probably should have here that these are labelled A and B. Definitely should have actually. So A and B there. Everything which is in B is everything in that B circle. Everything which is in A and B is in that sliver in the middle, because it has to be in A and B. And everything in A or B means it can be in A or it can be in B. And then the last one is this not symbol, so everything which is not in A. Brilliant. So let's start having a look at some of these then. Let's start having a look at these. So, to be honest, we've already got these down, so I think it's probably not worth getting these as examples. But let's just start thinking about what these questions are asking. So, identify the region shaded. So, the region which is shaded in this is that middle part here. Now, this represents A and B. So, the answer to this would be A and B. And that's what you need to write for this one. On that one on the right, well, I'll give you a second. Have a think about that and tell me what you think it is. Brilliant, we're flying through this. So this one here is A or B. Now remember, you've got to use this symbol here, this U symbol. This symbol here means or. Okay? A or B, A-U-B. Brilliant. So A and B, A or B, there we go. Right, let's have a look at this one on the right. So what is shaded in that? Well, it's everything which is, well, B is the only thing which is not shaded. Okay? This one here is everything which is not in B. So the way I'd represent this is it's going to be B with a not there, like so. Everything which is not in B. Now, this one under here, you might want to get this one down in your notes. Because the way this works is you're combining now two different things. The bit that's shaded, sorry, the bit that's not shaded, now that's important, the bit that's not shaded is the intersection, which is A and B. So what we want to say is we want A and B, but everything that's not A and B. So look, A and B is the middle part up here, which we'll go back to. A and B is that middle part, which is this part here. But we want everything which is not in there. And the way that we describe this is it's A and B, but everything which is not in here. Everything which is not in A and B. You might want to get that one down. Okay. So this one here says, which of the following shows A or B, not A or B? Okay, so everything which is not A or B. Well, which one here? So first of all, we need to know which one A or B is. Now, A or B, if I go back up to the top here, is this one on the right, isn't it? A or B is when everything is shaded. So we want everything which is not shaded in these three. So which one is that then in this question? Well, the ones which are not shaded, the three which are not shaded is diagram 4. So the answer to this one here is this one here, which is A or B, not A or B. Let's just go through these. We might as well do all of them. This one here, well, let's do the top one. This here is A and B. This one here is A or B. This one here is A and B, but not. So the bits that are not shaded like this. Brilliant. Okay, so this is now where we need to start to think about sets. So definitely let's get this one down in our book. This one here is example 1. Example 1. So list the members of A and B. Now you've got to know that this here means and. So what we're looking for is everything which is in A and B. Any numbers that cross over. Now you could, if you want to, actually draw a diagram for this. So if I was to draw this diagram, in fact I will show you this. So let's have a look then. So 2 is only in there. So 2 is in this side. 3 is only in A. So I'd just put 3 in this side. 4 is in A and B. So that needs to go in the middle there. 5 is also in A and B. So that needs to go in the middle there. 6 is only in B. So that goes on the right. And 7 is only in B. So that goes on the right as well. So list the members of A and B. Well, the things which are in A and B, you don't need the Venn diagram, but you can use it if you want to. So the things which are in A and B are going to be 4 and 5. So 4, 5 there, like so. 1 mark for that. Get that one down. And once you start to understand this, this becomes quite easy. As long as you know what those symbols mean. So that was example 1. Let's have a go at another example. So, let's have a look at this one here now on the right. This one here is example 2. Now, I am actually going to draw a Venn diagram for this. Now, so there's 3 things it's telling us here. The top line is telling us that in our diagram, in our Venn diagram, these are all the numbers. So this is the set of everything. Every single number here needs to go in my Venn diagram. In the left-hand side, I need these numbers. So in A, I need these numbers. And in B, I need the odd numbers. Now, it's probably worth at this stage listing the odd numbers which are in everything. So all the odd numbers which are in everything are going to be 1, 3, 5, 7 and 9. 1, 3, 5, 7, 9. Thought I'd missed some then. So this is all the odd numbers in our set of everything. Now this, remember this symbol here means everything. So let's now draw our Venn diagram. Now, last time I said to you, it's always worth starting in the middle and working your way out. And we're going to do exactly the same. We want to have a look at all of the ones, or all of the numbers, which are in A and B. So which ones cross over here? Let's highlight those actually. So 1 is in A and B. 3 is in A and B. 5 is in A and B, and that's it. So these are the ones which would go in the middle. So the ones that go in the middle would be 1, 3, and 5. So let's cross these out, because I've already put these in my diagram. Let's cross them out. So 1, 3, and 5 are now on my diagram. Now A has still got some in there. So the ones that aren't in B, but are in A, are going to be 2, so left over. 4 and 6. So 2, 4 and 6 go in the left hand side of A. So let's cross them out now. 2, 4 and 6. What needs to go in the right hand side of B are all of the odd numbers which are left over, which are going to be 7 and 9. So then I can cross off 7 and 9. And we're left with 3 numbers which aren't in A or B, so they need to go outside because they're still in this, and so it's going to be 8, just 8 and 10, isn't it? 8 and 10 are going to need to go outside. Now the question is asking for which of these, list the members in A or B. So we want everything which is in A, which is going to be this part here, or everything which is in B, which is going to be this part here, like so. So everything which is in A or B is going to be all of these numbers. Now I'll put them in order. So it's going to be 1, 2, 3, 4, 5, 6. And then the ones which are left over in B are 7 and 9. So that's everything in A or B. Brilliant. Now, have a little go at this one on the right. Now, you'll need to list out all of your odd numbers here. So take note, this is the set of everything now. It doesn't start with 1. It goes 2, 3, 4, 5, 6, 7, 8. You'll also need your prime numbers. Now, just a hint of your prime numbers. I'll give you a little tip with this one, actually. Your prime numbers in this are going to be 2, 3, 5. These are your prime numbers. 7. 9's not a prime because 5 goes into it. 11 is a prime. 13 is a prime, but it's not in my set of everything. Have a go at this one yourself. You'll need to draw the diagram. Have a go at that one yourself. So let's go through it together then. So, remember to start in the middle and then work your way out. So what are my odd numbers? I haven't listed those yet. So my odd numbers, I can't have 1 because that's not in my set of everything. So it's going to be 3, 5, 7, 9, and 11, because then 13's outside my set of everything. So which one are in both of these? Well, the ones which are on both of them are going to be 3's in both of them, 5's in both of them, 7's in both of them, 9's not a prime, but 11 is in both of them. So here I need to, right in the middle, 3, 5, 7, and 11. Let's cross those out. 3, 5, 7, whoops. 7 and 11. They're the ones which are in both. So my leftover odd numbers are going to be 9, which needs to go in this. And my leftover prime numbers are going to be 2. So let's cross those out. 9 and 2. And so the numbers which you need to go outside, which are left over, are going to be 4, 6, 10, and 12. 4, 6, 10, and 12. Now, as I said, you don't need to draw a Venn diagram for this, but I think it does help us. So what's in A or B? Now, you could just list everything which is in these two here, which is going to be 2, 3, 5, 7, 9, and 11. 2, 3, 5, 7, 9, and 11. Brilliant. Brilliant. So there's your answers. Super. So this is a past paper question. Now I wouldn't worry about writing out all of your whole numbers, but you are trying to find out. This is 2 marks. This is a question that has come up before. Have a go at this one yourself. Have a go at this one yourself. So the hint, if you're struggling here, is to write out the factors of 100 And we want things which are in A and B, so we need to see the multiples which are in that. I probably wouldn't draw a Venn diagram for this one. Okay, let's have a little go at this one together then. So if this was me, I would probably write out the factors of 100 first. Okay, so let's write out what those are. So I'd always do them in pairs, always. 1 and 100, 2 and 50, 3 doesn't go, 4 does go, 4 and 25, 5 goes, how many times does 5 go? 5 and 20, 6 doesn't go, 7, or does 6 go? No, 6 doesn't go, 7 doesn't go, 8, how many times does 8 go into it? 8 doesn't go, 9 doesn't go, 10 does go, 10 goes in 10 times, and I can stop there because I know I'm going back to 10. Now what we need to do is we need to think about all the ones of these, all of these factors which are multiples of 5, because I want everything which is in A and B. Okay? So which ones of these are multiples of 5? Well, I'm going to highlight them. 100, 50, 25 is a multiple of 5, 20 is a multiple of 5, and 10 is a multiple of 5. Brilliant. So the answer to this one here is I'm going to do them in order. Oh, I've missed one off, haven't I? What a silly Billy. 5 is obviously a multiple of 5. So the multiples here are going to be 5, 10, 20, 25, 50, and 100. So these are all the factors of 100, which are also multiples of 5. Brilliant. Okay. So we've got 2 questions here. These are already written in Venn diagrams. Have a quick go at those 2. I think you should fly through these. Okay, so let's have a look at these 2 then. So for the first one, we're looking for everything which is in A or B. So everything which is in A or B needs to be in both of these circles. So it's going to be this one, this one, this one, this one, and this one, and this one. Anything which is in both of these circles here, A or B, okay? Including this intersection. So I'm going to write these down. I'm going to write them in order. So 10, 12, 14, 16, 15, and 18. There we go. That's all of those in A or B. Now for this one here, we want everything which is in A and B, which is going to be this middle part here. Remember that this here means or, which means they must be in both of them. And this here, now the way I like to think about this is this here looks a little bit like an A for and. Okay, that's how I remember it. Okay, so this one here is going to be A and B. Which ones are in both of them? It's going to be 12 and 18.